How are you? You are becoming younger and younger every day.
So weight is increasing. That's why.
Good. That's required nowadays.
He
But
did
you are
not.
looking very fresh.
He did not take care of color for the last few weeks.
No, Dr. Chetty is looking very fresh. I mean, I think
He is always fresh. my friend.
he's very high in spirits, it seems.
Oh yes, yes. He is always fresh.
Oh, Niranjan
Hello,
Da.
Rajgupta sahab.
Good afternoon, everybody.
Good afternoon. Good afternoon.
Good afternoon, Nilanjan.
Fine. Going on. Let me just increase the volume here. Yeah, I think I can hear now properly. The volume was a bit lower.
Anupam is thinking something. Yeah. আপনি গেলেন তো এদিকে আমি ভাবছি যে কোথায় গেছে
বসে আছি
I could see Sudipta moving behind.
Yes, I'm here.
কেমন আছেন?
Finally. এলাম শান্তনুর জোড়াজুড়িতে ভালোই
good.
আছি
Great,
কিন্তু
great. Great
আর
to see you after
I
some time.
don't feel like giving lectures anymore. I'm relaxing all the time.
A lecture,
This
giving
week
lecture is a
far better, huh?
way of life for a teacher for so many years. So
Mara,
আপনি
I'm retired for
will be
long
relaxed only.
years. I'm retired
Madam, good afternoon.
Good afternoon. তো ধ্রুবদা এসে গেছেন
Sir, good afternoon.
Good afternoon.
Namaskar, sir. Namaskar, madam.
I was telling Shantanu that I'm giving this lecture possibly for last 40 years. So most of you must have heard it 10 times or more. The senior persons are
Madam, many of us got interested in geology by reading your book. After reading your book.
সেগুলো তো এনসিয়েন্ট হিস্ট্রি
না,
এখন তো সবাই যাচ্ছে
হ্যাঁ সেটা যাচ্ছে লিখছে কজন এরকম পপুলার লেখা এবং এনকারেজিং লেখা
না ইংলিশে লিখেছে দু একজন বাংলায় অবভিয়াসলি লেখেনি ইংলিশে কয়েকজন লিখেছে
I think it is better to use official language.
Yes, I think
sure.
I think most of our students in this sector come from different districts where their medium has been vernacular medium during their 11, 12 and Madhyamik region. So more such books in vernacular languages are required to motivate students. Otherwise, yes, we have books in English, no doubt, but we find that our majority of our students are from districts who have studied throughout their life in Bengali.
Yesterday, one of my, what should I say? Anyway, a person who were much junior to me and read Antarctica and got inspired to write books in vernacular language. And he's an astrophysicist.
Oh.
So he wrote a book on really interesting about stars, planets, and existence of life in other stars in Bengali. Groho Grohantare Jibon Bole. It's really.
Who's
really,
the author? Who's the author, madam?
Huh?
Who's the author, madam?
Sujan Sengupta.
Okay.
He's an astrophysicist in the Astrophysical Center in Bangalore.
Okay.
তো খুব ভালো লাগছিল বাংলায় পড়তে বেশ ঝরঝরে বাংলায় লিখেছে আর বেশ কঠিন কঠিন ব্যাপারই লিখেছে তো
Another student of yours, our senior by 2-3 years, Abir Gupta, you may remember him. He was in GSI and he used to write books on geology in Bengali and used to publish in Kolkata Book Fair. When I was in GSI, that time he was writing. I don't know. I mean, nowadays I don't.
Abir Gupta. Oh.
Abir Gupta was a classmate of, I think, either Nibidda or just 1 year senior to him.
Oh, I see. Acha. Amitabh Banerjee bole GSI, someone from GSI. He writes quite often.
I don't know whether any of you know that Professor Shubhir Ghosh wrote a structural geology.
Yes,
book.
yes, sir.
Yes, sir. Yes, sir.
Yes.
But
Sir, that was a very good book we used to
Nora.
have with us, but now I have lost that copy and it is now out of print. You cannot get it.
Yeah, that's the problem. So many people has asked about this book.
It was a
But
very
it's
good
out
book.
of, and the publisher is
published
Paschim
by the
Bongo.
West Bengal. I think it was the
Rajya
book
Pustak
board,
Parshad, the West Bengal.
which is now
Raju
a
Pustak,
defunct
and there is no
organization.
chance of retyping it, I think, republishing.
During that time, many of the books were in Bengali. Also. Timir Babu also wrote a book in
Yes,
Bengali.
Yes.
Stratigraphy also was a very good
Right.
book.
Yes.
Yeah.
So if somebody has the copies, then we can make a PDF of those. I mean, that's not a big problem nowadays.
I got a copy of Shubhir Babu's book, but I was thinking approaching some new publishers and get the permission to republish it, because lots of publishers are interested in publishing scientific books in Bengali.
I know of some of the publishers, madam. So maybe I can give you some names.
No, you can contact them.
Fine, I can.
If
Also.
you finalize high, then we can all talk
Okay,
together.
fine. Yes.
Because I don't know about copyright. If Obhik, his son, got the copyright, he must also give permission.
Yes.
It will not be difficult, I think, but
No. You will be interested. Yes, sure.
Yeah, Jyotirmoy, I think it is now 5 minutes past 4, right?
Yeah,
So will we wait for another couple of minutes, or we'll start?
yeah. Let's wait for 2-3 minutes. I think.
Okay. So in the meantime, can I, because today myself and Professor Sengupta is together, because her laptop is malfunctioning, so she will have to do it from my machine. So
Okay.
the thing is, can I just try it once, whether everything works properly?
Yeah. Please go ahead. Yeah.
Please.
Just
actually, recently I bought a book, Sudipta, I bought a book over Amazon. There is a lady in GSI, now presently much junior to us, called Maitreyi Rai Maulik.
Oh yeah. She was our student. Yeah.
Achha, she was a presidency college student. I don't know her personally, but she has written a book on the initiation of that Sakchi, the Jamshedpur steel mines, these things. Discovery of that by Pramodnath Bose, and then making it over known to the Tata Industries, and then the whole iron industry or steel industry of the India started from that. So that is a very good book. I was reading that with a very detailed historical account of the geological developments of that time. Chaka Ghoda Rage. That is the name of the book.
I would like to buy that book.
He has also
It's a
written
beautiful book.
on
I have
William
bought
Smith,
it.
on the first map produced by William Smith.
So that book I have by Simon Winchester. That is the map that changed the world.
That was in Bengali.
translation of
Original
that
is in
book, yeah.
Bengali.
Yeah.
Okay, that I have not seen, but I have the original book, and I have seen that map in the Royal Society office in London.
No,
that
what
map is
you are
very
talking about, that's a English book, original English book.
Yes, I understand. Yes,
But this
Simon
one,
Winchester.
Maitri wrote
that
like
book
a
I have.
novel.
Yes.
Maitri wrote like a novel, like she did for the Bosch book also.
Okay, that book I have. That Bengali book I have not seen, but this book on the discovery of iron ore mines in Orissa by Pramodnath Bose, and then talking to Jamshedji Tata and handing over the information to him and encouraging him to start the captive mine industry. That is a very good book, and with very detailed description of the geological developments. I liked it very much.
Yes. You will
Jyotirmoy
like
is-
William Smith
Yeah,
book also.
we can see the screen, however, not the presentation.
Oh, really? So I have to go back again because there is some issue is coming up. I could see that. Okay. Please carry on your.
That William Smith map, sir, it is displayed with, very high honor in the Royal Society office in London.
Yes.
When I visited there, I saw that map along with Darwin's book and this in Newton's Principia Mathematica, they also have displayed William Smith's map as the first pioneering work in the world. That was very nice to see that a geologist has got that kind of a status.
Lyell's book was also there.
Lyell's book is also there.
Shantanu, try presenting the full screen.
Yeah, entire screen. But there is some issue coming up for system preference. Google Chrome might not have screen recording permission on your computer. We don't need that.
No,
Just a minute. There is some issue with this. That's the reason.
Anupam, the Delhi is still cold?
Delhi is still cold, but not that that bitter. Now, actually, sunshine is coming off and on. Today it is cloudy. Possibly a rain is coming, but it is generally cold day condition is continuing. This is the longest cold spell that I can remember in recent years. Almost for a month, we are now having fog and cold.
Actually, every year we are moving to a higher latitude, na?
Actually, so. Global warming is also leading to global cooling to some extent. That our Professor Maurice, Professor Maurice Tucker, whose book we read, the sedimentology, I had a talk with him in Durham. So he was telling that what is the problem if you have a global warming? Okay, the ice will melt from the higher latitude, then we shall put there and let the other thing be desert. So it is something like that. So it doesn't matter in any case.
Yeah, we are unfortunate that the Gondwana line broke. Otherwise, we would have been in a very good position.
Jyotirmay, this problem is persisting.
I think Shantanu is lost out.
Shantanu is trying to sort it out. There is no problem with the link. I don't know why the presentation is not coming up.
This is the problem of having very high-end laptops.
The laptops also age. My laptop is old, of course, not very old, but about 7 years. And now I have seen that it has become extremely slow. Tube-like type. So if you give some instruction, it takes at least half a minute or 1 minute to understand what I am trying to tell him.
No, but that is not the problem with Shantanu's laptop. It's the most recent one, probably.
I think there is some issue in the, I don't know. I mean,
In the net, it could be net problem also. In Sudipta's house, I don't know. Jyotirmay can call him once if you.
It's again coming. Yes, Shantanu, we can see now. Yeah.
I hope now you can see the entire screen, right?
Yes.
Yes.
Okay.
Yes.
Jyotirmay, I
Just,
hope
Shantanu, just check whether it is moving or not. The slideshow is moving or not. Just check. Yeah. It's moving. Okay. Fine.
Okay.
Fine. Fine.
Okay.
Yes, Jyotirmay, please start.
Shall we start then?
Yes.
Sure.
Okay. All right. Shantanu, I can't see you or ma'am.
Okay. Sorry.
You can.
Just a minute.
কি করবে আবার?
আপনাকে দেখতে পাচ্ছে না? Yeah.
Yes, now it's fine.
Okay.
After for several months, I believe we have now 50 participants in this
57.
presentation. So congratulations to us and congratulations to Madam.
Thank you.
That's great.
57 and counting.
Yeah.
It's Sudipta's glamour that has attracted
Arey.
so many.
বাবা আমি তো বেলুনের মতো ফুলে গেলাম I'm just blown.
We expect more
Actually,
to
you
join.
have to add one more always because Madam and Shantanu are there together.
Yes,
So,
that's true.
yeah.
A background and an anomaly.
Okay, let's proceed for the reason why we are here to hear from ma'am. Welcome everyone, and I wish you a very happy new year because this is the first virtual talk of this year. And we are extremely glad and privileged that Professor Sudipta Sengupta has agreed to deliver a talk today. And I think she requires no introduction. Everyone knows her. But anyway, being the convener of this forum, let me just say one or two words, one or two sentences, and then everyone knows about her, so my job is pretty easy here. So Professor Sengupta is a professor in structural geology, and she was associated with Jadavpur University, Kolkata. And she's also a trained mountaineer. She is the first Indian woman, along with Aditi Pant, to set foot on Antarctica. She is popularly known in India for her book Antarctica in Bengali and numerous articles and television interviews on geosciences. She has published extensively in international peer-reviewed journals on structural geology. She was awarded with the Shanti Swarup Bhatnagar Prize from CSIR. And of course, she has studied, did her BSc and MSc both in Jadavpur University as well as PhD from Jadavpur University under Professor Ghosh. On a personal anecdote, of course, many of us have started learning, including myself, have started learning structural geology from her. I remember my first class, the first lesson of structural geology was from ma'am. And, it's extremely happy and joyous occasion to welcome you, ma'am, to this forum. And with further ado, I welcome you to please talk about Antarctica today. Thank you, ma'am.
Thank you, Jyotirmoy, for this nice and kind introduction. I'm a little hesitant about delivering my talk today because I was telling Shantanu that since last more than 40 years, since last 40 years, I've been delivering this talk so many times that I'm sure half of the audience have already heard. But they have to bear with me again because I have been talking the same, giving the same Antarctic lecture. But I believe a visit to Antarctica is always, doesn't matter how many times, it's always fascinating. So I'll be very happy to share my experiences with you. Thank you.
So I think this is the slide.
Okay, today my topic is Antarctica, a continent for science. So the talk is mostly based on my 2 expeditions to Antarctica. The 3rd expedition in 83-84 and 9th expedition in 89-90. But after that, I was I'm still associated with Antarctica by in various stages, in various way. So let me first give an introduction of Antarctica. The name Antarctica was given by the Greeks in 2nd century BC. Actually, they believed to balance the northern continents in the northern hemisphere, there must be a large continent in the southern hemisphere. And since one cannot see the Great Bear, the Arcticos in Greek language, from that continent, they named that large continent as Antarcticos. But it took many more years to really check whether there is a large continent in the southern hemisphere or not. After the discovery of Australia, the first voyage below Antarctic, below the southern sea, was taken by James Cook in 1772. And for 3 years, he circumnavigated the southern hemisphere, but he couldn't reach any farther than 66 degrees some south latitude. But he was the first to cross that Antarctic circle. His two ships were Resolution and Adventure. But what happened that he reported a number of whales and seals in the southern sea, which attracted all the whalers of Europe and America to visit southern sea. And these are the whaling farms who are the first explorers of Antarctic region. And these whalers first there was three claimants from these whaling farms, one from Russia, Bellingshausen, one from America, Nathaniel Palmer, and one for UK, John Bransfield. In 1812, almost simultaneously, within 1 or 2 months, they believed that they saw Antarctica and stepped in Antarctica mainland. Before that, they visited all the Antarctic, subantarctic islands, but that they are the one who claims to step foot on the first, on the main continent. After that, the two British from the whaling firms, Weddell and Ross, they did maximum exploration in this continent, and most of the mapping was done by these whaling farms, and they are the first geographical explorer of Antarctic region. After that, there was, after the whole map of Antarctica was established, there was a race to go to the South Pole. And that is actually termed as heroic age. From the start of 20th century, there are innumerable number of expeditions of really brave heroes who almost lost their life in this pursuit, but they carried out excellent work. Amundsen was the first to reach Antarctica, but Mawson, Scott, and Shackleton, they carried out lots of scientific research as well as exploration. And in December 1911, Roald Amundsen reached the geographic South Pole, and followed by Scott a month later. But what happened that time, the scientific interest started to grow about Antarctica. A lot of countries, mainly 10 or 12 countries, they are sending expedition, and since they are still in that colonial age, they are claiming territory in Antarctica. Some of the claims were overlapping, some of them were isolated. Only I think USA and USSR didn't do any claim, those who were going to Antarctica in those days. Fortunately, during International Geophysical Year 1958, the scientists all over the world met, and they decided that scientific expeditions will be taken in Antarctica because Antarctica is in an unique position, because there are no polar continent in this world, since Arctic is only a sea. So they will build permanent research station in that continent and carry out research, preferably all year round. And the scientists force the politicians, that is their government, to sign an Antarctic treaty which stopped or froze the territorial claim on Antarctica. And there were original signatories were 12 countries. Now there are actually 56, not 42. I was reading this much long years ago. Now there are 56 countries who are signatories to this treaty. And this treaty stops or freezes any territorial claim on Antarctica. And it was decided that Antarctica shall be used only for peaceful purposes, and anyone can go and do scientific investigation there, and they can cooperate amongst themselves. All these results will be freely exchanged, and nuclear explosion or disposal of radioactive waste is prohibited. And this area, this prohibited area, includes all the land, ice shelves, and sea below 60 degrees south latitude. Now, why the scientists are so interested in Antarctica? This is, as I said before, that it's only polar continent. This is the only one single polar continent. Then there are the glaciologists who believe that ice shelf will give us a lot of information about our geological past. Then biologically, lots of endemic fauna and flora are present in that southern ocean, which will be very interesting to study. And of course, geologically, it's a key piece of Gondwana land. For upper atmospheric scientists, the aurora, the ozone hole is a matter of interest. And the Antarctic weather controls the world weather. And of course, environmentally, it is the benchmark for pollution. Now, this is the map of Antarctica. If we take our eye below the globe, this is the only polar continent. Nearest continent is South America. And penguins are only found in Antarctica for these biological studies. For geologists, Antarctica was attached to all the other Gondwana-led countries. And ozone hole was discovered in Antarctica, and for the first time, and its presence has been noted. And since then, a lot of restrictions have been used to prohibit uses of CFC gases. And of course, because of the Earth's southern magnetic pole is situated there, any particles from solar particles or outer space particles are attracted and enters the Earth's atmosphere vertically in the polar region. And we can see auroras, phenomenon like auroras and other features also, only because of its presence of magnetic south or north poles. And of course, the Antarctic weather controls the weather of the rest of the world. India first joined this venture in 1981 and 82, when Dr. Syed Zahoor Qasim took the first Indian Antarctic expedition to Antarctica in 81, and they landed there in January 82. I was fortunate to join the third Indian scientific expedition in 83. And myself and Dr. Aditi Pant, a marine biologist from NIO, was the only two women scientists, and we are the first women scientists Indian women scientists to work in Antarctica. Now, Antarctica has very many adjectives to it. It is the coldest, driest, highest, and windiest continent. And it contains both the South Pole, geographic South Pole, and magnetic South Pole, which is somewhere here these days. And minimum temperatures were recorded in Vostok Station somewhere here, which was minus 88 degrees Celsius. And our Dakshin Gangu station, the first Indian station, which was the main purpose of third expedition to build, was situated around this area. Antarctica is quite a large continent of 14 million square kilometer, and the ice volume is huge, about 30 million cubic kilometer, and average depth of this ice shelf over Antarctica is 2.5 kilometer. At places it can reach up to 4.5 kilometer. And because of this huge volume of ice, the Earth's crust is depressed there by 600 meters. If in some future this whole ice shelf is melt, then the sea surface will be raised by 60 meters. So all our coastal region, including Bangladesh, our Kolkata, or even Bombay, everywhere will be all flooded. And Southern Sea is the richest biological reserve, has the richest in the world. Now, Antarctica seems like a single continent now because of the overlying ice sheet. Otherwise, Antarctica is actually a conglomeration of a different, a number of islands. So on the right side, you can see these are the land. If Antarctic ice sheet ever melts, this will be the land feature. And it looks like that in present. Only the rocky 2% rocky exposures are allowed Transantarctic Mountain or Antarctic Peninsula or around the coastal region in some places. And surrounding Antarctica, the sea ice is also frozen most of the year. Only in summer, some part of this ice is melt, and it is possible to reach Antarctica in austral summer. Now, in 83, we went there by ship. That was the only way to reach Antarctica. Most of the places can be reached by ship there. And we hired a Finnish icebreaker ship, and it's called Finn Polaris. And we started our journey from Goa. And after crossing Mauritius, we crossed the 40s, 50s, and 60s. You all of you heard about furious 40s, roaring 40s, furious 50s, and screaming 60s. So we have to cross that very, very rough sea zone where waves can be meters high and there will be rolling pitching of the sea. But after that, after crossing 60 degrees south, we crossed the Antarctic convergence with the warm water from the north and the cold water from the south meets. And after that, we only saw this broken sea ice covering and temperature suddenly drops. And gradually, as we move south, the ice gets frozen, and it becomes totally covered with this broken frozen pack ice. And that is the situation usually in Antarctica. In summer, this broken frozen pack ice surrounds Antarctica, and the ship has to move very carefully. Only the icebreaker ship can move there, penetrate that ice, and try to reach there. Now, this is the shape taken from helicopter and how they are maneuvering through this broken pack ice. Now, after this pack ice, we met a clear water which is called polynya, and then there are freshly broken ice, sea ice, and these are called fast ice because they still remain fastened to the main ice shelf. And this is the fast ice, unbroken sea ice for that year, and usually the thickness varies from 1 meter to 5 meter, and our ship could not penetrate this thick sea ice, unbroken sea ice. So we landed here, and all our materials, the expedition materials, were unloaded on this fast ice. And this sea ice is totally different from the main sweet water ice of Antarctic landmass. This ice sheet contains 90% of the world's glacier ice and 75% of the world's sweet water. And it's approximately 15 million year old. Some places it may be older, some places may be younger. And average depth, as I said, is 2.5 kilometer. Maximum it can reach up to 4.5 kilometer. And this shelf of this ice shelf looks like very soft, like we see melt ice cream, but they are very hard. If it hits the ship, it can cut the body of the ship like a blade cuts paper. So the ships are always very careful not to go very close to that ice shelf. Now, a cartoon of this cross-section of the Antarctic ice sheet, and some part of it's like a dome-shaped ice sheet because of this is the normal continental features, mountains, valleys, etc., and which is covered by, say, average 2.5 kilometer ice sheet. And at places, if the height of the mountain is higher than the ice sheet, then it juts out and are exposed. Part of this ice sheet is floating beyond the continental margin and floats as a ice shelf. And this parts of this ice shelf, due to gravity, moves as ice bug. Now, it shows the separation of this ice bug from the ice sheet is called calving. And these ice bugs can be few square kilometers to few hundred square kilometers to few thousand square kilometers. Maybe sometimes it can be as big as a small country like Holland and Belgium. When it forms iceberg from the main ice shield, it causes fractures, and then fractures continues down the depth. As you know, all iceberg have almost 1/10 below the water, and visually you can see layering just like sedimentary rocks on the top of these icebergs. But you can measure the age of this ice, but as you go under some depth, visual ice becomes so compact that visual identification is not possible. Then one can with the help of carbonate, with the nuclear dating and all that, you can measure the date from the ice core. And when it breaks from the main ice shelf, its shape is a tabular like this one we saw, and gradually due to weathering of air, water, it breaks down to smaller pieces, ice caves are formed, and then it becomes smaller and smaller as it moves north. And one big iceberg can move around Antarctica for years, sometimes 10 years, even 15 years. These days, the ships are not scared of the icebergs because Titanic will never happen again, because all the icebergs are monitored from the space and the ships have this access to this data. So they avoid these icebergs. But when the icebergs are very small, like they are called growlers, and which cannot be identified from the space, and this had to be visually identified, and the ships has to maneuver very carefully through these growlers, otherwise it can damage the ship. Now, icebergs or sea ice is completely different from the continental ice sheet. When we reached there, this is the first day, photograph was taken on the first day or first few days, I don't exactly remember. And it was a very clear day, and there were a vast expanse of white ice shelf and very transparent air. So the visibility is so clear that you can see miles after miles, and you always underestimate the distance because we are not used to that clear visibility going from cities and towns. It is this kind of visibility is only possible in Antarctic atmosphere, where there is hardly any dust or anything. And since it was summer days and it was 24-hour equal daylight all around, and it was not possible to determine which time of the day it is, day or night it is. So we have to rely on our watches. But the sun moves, and the sun moves around the horizon at equal height, but it never goes over our head. It moves over circumnavigate the horizon at same height, and as days progress towards the end of January, the sun first touches the horizon, and we have the first night in Antarctica that time. Otherwise, and since then the sun will go a little bit more and more under the horizon, and the length of the night will be more and more as it progresses. And in March, 21st March, it will be same length of day and night. And then it will go farther down, and then in mid-July, there will be no sun for next 3 months, and then again start to, in exact southern pole, it will be no sun for 6 months, but where we went, it goes down for 3 months, and then next, the summer begins again. Although it shows a flat ground, but Antarctic, there will be sometimes is undulation, just like sand dunes in desert. Antarctic is nothing but a dry desert, and these are called sastrugis, formed by air action. And this ice shelf storage lots of information, not only about paleoclimate, but all the meteorites, mini meteorites, they are collected in this ice shelf and frozen for thousands of years. And this meteorite, when it forms anywhere in that ice shelf, usually because of the presence of this high mountain range around the coast, they are the sort of treasure trove of meteorites, because due to snow flow, all these meteorites flow towards the coast along with the gravity of the whole ice sheet, and then get stuck on the inner side of the mountain. So all the scientists who work on meteorite go there and collect a large number of meteorite from the inner side of these mountains. Another interesting feature in this ice sheet that in presence of many glacial lakes under the ice sheets. In 1974, a large glacial lake was confirmed below the ice sheet by the British group, and they are joined near Vostok station, and that's why it's called Lake Vostok. And jointly with the Russians, USA, and British, they tried to find this started to code this area to reach this freshwater lake through the ice sheet. So they started to board in 1996 and finally reached this under ice freshwater lake in 2012, and but it was contaminated because it was not easy to collect uncontaminated water from the lake through the process, and then finally collected uncontaminated ice water in 2013 and again in 2015, and now researchers are going on this water, and they found a variety of organisms, living bacteria and other organisms in this water, and the very interesting results are coming from this. Now, as we reached there, our main activity was carried out by the helicopters because we could not reach the main ice sheet, and our purpose of the expedition was to establish a permanent research station. So the activities were carried out mostly by the helicopters. We had 2 Air Force large helicopters from Russian Mi-8 and a number of, I think about 4 Alouette French helicopters. We called it Chetak helicopters from the Navy. And the base camp was set up on 27th December with mostly with these are the Antarctic tent from British Antarctic Survey, and which withstands 200 kilometer per wind speed, and it's very strong tents. But unfortunately, on 29th December, we had an accident. All the large porta cabin and the large building materials were carried underslung to the continent. And one day, somehow it was windy, or there was some pilot error that the helicopter did not lift the load up to a certain height, and the load crashed with the crane weir of the ship, and it crashed in the icy water. Fortunately, it crashed on the water because otherwise on the other side there was the ice shelf. So it will be a more dangerous accident then, and we would have lost all the lives. But in the water, although the water was very cold, minus 1.8 degrees Celsius, but the 5 occupants of the helicopter could come out from the helicopter, and the other helicopter and the boat rescued them. So all 5 of them, although they were very thermally hypothermic situation was there, but their lives were saved. The main purpose of the third expedition was construction of permanent research station Dakshin Gangotri, and it started in January full force and almost going very fast. Actually, it was the first and only record of building a station in one Antarctic summer. But the geologist and physicist and the biologist, 5 of us, we went to a small mountain range inside, 70 kilometers inside from the coast, and we set up our camp there to carry out our field work. It was the small Wishes mountain range is called Shimakar Hills. And here are 3 of our geologists, Madan Lal, R.K. Singh from Geological Survey of India, myself from Jadavpur University, Prabhu Matondkar from biologist, and Dr. Banerjee, who was medical doctor. And we all set up the camp in Shimakar Hills. And 2 geologists who also had their station in the same Shimakar Hills near the Russian station Novolazarevskaya. That was also present in that same mountain range, came to visit us, so the picture was taken then. By the time we spent 1.5 months in Shimakar Hills, and we returned from Shimakar Hills after completing our task. Dakshin Gangotri, the permanent research station, was complete, and inauguration was done on 26 February 1984. I joined another expedition to Antarctica in 1989-90 season, the 9th expedition. And that time, Dakshin Gangotri, after 6 years, was almost submerged in the ice. And I was present during the inaugural session, and I was also present in the closing ceremony of Dakshin Gangotri on February 1990. But by then, on the Shimakar Hills, we have a new station, which is called Maitri, which is still working these days. Unfortunately, on 8 January, after we just started our work, and we set up our camp in the Humboldt Mountains, which is another 100 kilometers south of Shimakar Oasis, 4 members died in one accident. They died for carbon monoxide poisoning. 3 of them were my co-workers, 3 geologists from Geological Survey of India. So we had a big jolt, and our leader was also a geologist. So although we had lots of plans of our work plan to work there in the Humboldt Mountains, we have to revise that plan. And as he was too busy to deal with that situation, because the 4 bodies had to be sent to India through Russia, and a special plane was arranged to carry these bodies to India, as their family demanded that. So I had to do detailed work by myself most of the time in Shimakar Hills. Afterwards, Rasik Ravindra, who was the leader and geologist, and Amitabh De, who was another member, and me, carried out some field work in the Humboldt Mountains. Now, let's start about some interesting facts about Antarctic. Antarctic landmass, because there is no plantation except in the Antarctic Peninsula, there are some grasses, but otherwise only plants are some moss and lichens. So there is no no kind of animals in Antarctica except for some small flies or something like that. But on other hand, the water in Antarctica is very rich in nutrient because the annual freezing and defreezing of water churns out lots of minerals, which supports a huge variety of uh, water flora, and which in turn supports a huge variety of animals. So this is the uh, main food in the food chain of Antarctica, krill, which supports lots of fishes, penguins, seals, and whales. These are crustacean, just like our little prawns or shrimps. But some places in Antarctic weather is so rich in their presence that the water looks pink, and they are still the main source of food of all Antarctic animals. Most important of these Antarctic animals are, of course, the penguin birds. They cannot fly. They are very endemic to Antarctica, but they can walk like human being, and sometimes when they are in hurry, they slide like toboggan. Mostly two varieties of penguin are present. These are Adelie penguins. These are very curious, and if you don't sort of move in a quick motion, they come and look at you or come close to you. Here you can see one is close to me, another is trying to look through this man's camera, that what's happening there. So they are very friendly birds. The second variety of penguin we saw are emperor penguins. They are very large, almost 4 feet height and 45 kg in weight. They have both these birds have thick layers of fat in their body to protect from cold. And these emperor penguins are especially very curious kind of birds because they breeds in the thick winter of Antarctica when the temperature is minus 45 degrees Celsius. Usually they build nests, or they huddle together in a rookery, and the female penguin lay one egg, and after laying the egg, it transfers it to its mate, and the male penguin incubates the egg for 2 months. During this period, the female penguin goes to the sea, and for 2 months, the male penguin don't eat anything, and it nurtures the egg. Sometimes the little penguin may hatch, or sometimes the mother will come. Otherwise, they never let the egg or the small chick on the ice. So it's protected, since they don't grow scales in their body or feathers in their body. They protected them for their cold. So this is the situation in a penguin rookery when thousands of penguins collect together, and they keep warm by staying close to each other and changing sometimes places from inner circle to outer circle. And the small penguins are protected from cold weather. By the time they develop a little bit of feathers, the summer comes, and they have a bigger chance of survival. There are other two types of penguins, or other few types of penguins, but we didn't see them. Another interesting bird is skua. We saw these skua birds in Shimakar Hills also, and they are scavenger birds, almost the same size of eagle, and they are very ferocious birds, and sometimes they attack human being also. The Antarctic seals again is endemic. Antarctic area is endemic. Seals are endemic in that area because the northern seals can use their limbs, whereas Antarctic seals, they remain in the water for more time because the water temperature is never colder than 1.8 degrees Celsius, minus 1.8 degrees Celsius, whereas outside temperature may be minus 30, minus 40. So that's why they lost the use of limbs, and they drag their body over the ice. And there are 4 varieties of seals. Crab eater, they are the most common. This is our ship, and we saw this huge colony of crab eater seals during my second expedition. And these seals have thick layer of fat in their body, and they have the capacity to squeeze all their blood vessels in winter and keep the inner part warm so that it can survive the cold winter. All the seals, all the other seals mostly live on krills or other small fishes, but leopard seals are carnivorous. They live on other penguins or other small cubs of seals. And very rare are the Ross seals, but we are lucky to have a glimpse of one Ross seal during my second expedition. Antarctic Peninsula have a 5th kind of seals, which are called elephant seals. They are huge and they have a long proboscis, so that's why they are termed as elephant seals. And another interesting animal there is the orca or killer whales. They are very common in Antarctic water, and they are very clever. They can communicate with each other and attack their enemies by communicating in groups. So we also, this photo was taken one of my during second expedition. One of the member of the crew, ship crew, was a very eminent photographer. He took this picture. There is another variety of very interesting fish in Antarctica which has white blood in their body. There is no hemoglobin. The Antarctic water is so rich in oxygen that this fish can transform oxygen from the water to their body without the help of hemoglobin. And this also contains in their body some kind of antifreeze so that they can stay alive even if they are trapped in ice, even if the sea freezes. Now, let's come back to geology. And as I told you before, that Antarctic landmass is only 2% of the whole area, and they are mostly exposed along these Antarctic mountains and along the coast of this East Antarctica or around Antarctic Peninsula. This part is Precambrian. This part, Transantarctic, is mostly Devonian or Carboniferous, and this part is younger. So the Western Antarctica Peninsula is the youngest part. It is not exactly, it is in a way extension of Andes orogeny, but much more complicated than that. These are mostly Mesozoic and Cenozoic rocks. Antarctic mountains are geologically most interesting area because it is mostly Paleozoic age and contains abundance of plant and animal fossils and coal beds also. That Antarctica was once upon a time is very warm continent full of forest covers is proven by these fossils. And some of these are, of course, sedimentary rocks still in their horizontal position. This transantarctic mountain also has a complicated history. They are folded mountains of originating belts plus uplifted many times, then again peniplaned and again uplifted. So they have also a very complicated history. This is the fossil tree found in the Beacon supergroup, which is present in on Indian all Gondwana land continents. And again, the Gondwana land fossils in transantarctic mountains. There is a very nice anecdote about this Glossopteris phenom. After Edward Swace proposed this Gondwana land, Mary Stopes, a paleobotanist, famous paleobotanist, was very interested, and she was studying Glossopteris fauna of Africa, from South America and this region. And she was sure that Antarctica also contains Glossopteris. Then the picture will be complete, whatever Swace suggested. And she, by chance, met Robert Scott before his Terra Nova expedition and requested to be a member of that expedition. But because she's a woman, the Scott did not include her in the expedition, but promised her that they will look for Glossopteris flora. And Scott has a very, Scott's companion, Edward Wilson, who was a scientist, a biologist, and a geologist, not exactly geologist, but geology enthusiastic, who perhaps many of you read their journey to collect penguin eggs in the winter of 1911, when Cherry Garnered, Edward Wilson, another member, did a journey to collect these penguin eggs in the from their base camp. And Cherry Garnered wrote about this expedition as the worst journey in the world, which is very famous. Anyway, so Scott promised Mary Stopes that they will collect fossil for her. So Edward Wilson found a Glossopteris fossil and he collected it. But when they are very tired, when they're on their return journey, they were very tired and can't even walk. They did not leave any of the rock specimens or any other specimen, whatever they collected. And when all these members died, just 11 miles short of their base camp, and their dead bodies were found 1 year later by the other members, they found these Glossopteris fossils specimens by their bodies, next to their bodies. So they kept their promise given to Mary Stopes about bringing these Glossopteris flora back to. So anyway, another interesting creature in Antarctica, which is present in most of the Gondwana land countries, are these Lystrosaurus, whose bones are also found in transantarctic mountains. As opposed to that, the west and transantarctic mountain, the East Antarctica is completely unfossiliferous and contains of Precambrian basement rocks. And we walked in the Humboldt Mountains area of East Antarctica, of Quinman land in the Dronningmond land, or Dronningmond of East Antarctica. And other part of very well studied part of East Antarctica, we can understand the geological features of tectonothermal development of East Antarctic land with the studies of the geological studies by the Australians and Russians in several isolated places like Enderby Land, Cape Land, Princess Elizabeth Land, and Queen Mary Land, Wilkes Land of East Antarctica. And East Antarctica, of course, has a very complicated history, as all Precambrian shield has. And we studied a small part, a small mountain range of Schumacher Hills. And I will just give a small pictorial summary of those geological description of the area. Although a lot of studies have done since then, but this is almost, you can say, the basis of our study in that area. So this is the Schumacher Hills, which is a small hill range about 35 kilometer length and about 3 kilometer in width. And they contains mainly granulitic rocks, and it suffered polyphase deformation and metamorphism. And the earliest deformation is found in few isolated enclaves. And these are very interesting. These enclaves gives us lots of information of ultramafic and mafic area of bearing pelanorite, chrome, spinel orthopyroxenite, and a lot of other mineral, which shows the mineral composition shows that they are formed in a lower crustal condition at 11 kilobar and 900 Celsius. And these are deformed by later deformations, and sometimes this showing different angular orientation of the inside foliation with the outside foliation, like this one, and partially amphibolized in places. Sometimes if they are a long unit, it can be folded, showing axial planar foliation of the D2 deformation, which is also of showing granulate facies deformation. And they also were deformed under 8 kilometer and 800 to 800 Celsius temperature. And mostly they are endebitic, and mafic dikes are interlayered. Then there are few high strain zones showing shear zones, but showing grain refinement, but no real myelonitic reduction of myelonitic not typical myelonites, I would say, because the sheared granulite gneiss also are actually gneissic rocks, not exactly myelonites. Then the third deformation is under amphibolite facies, where all the earlier rocks has been retrograded, and there are strong mineral lineation and budinoid formations related to all this deformation, and emplacement of mafic dikes. Mostly all the dikes are all the deformation have synchronous dikes, but the earlier dikes are very deformed, and sometimes torn apart, and amphibolite dikes are very more common in that area, with quartzopathic fringes like this one. Then the later events, there is open folds, which didn't develop any axial planar foliation, but still under amphibolite facies metamorphism. And they also contain two sets of ductile shear zones. And the latest feature is a unmetamorphosed strike crossing all the earlier structures. I won't go into detail of this history, just repeated deformation and metamorphism. Now, again in 1995, I got a scheme to work there with my students. And that time Shantanu joined as a PhD student, and he was very enthusiastic, and he went there for 3 consecutive years from 95 to 97, and completed his PhD thesis there. And he was accompanied by Shushanto Samanto for 2 expeditions, and Sugato Hajra for 1 expedition. So in 1998, National Center for Antarctic Research was set up in Goa, and it is now it's named National Center of Polar and Ocean Research, because they have a program in Arctic also, and they have established another research station in Arctic called Himadri. And if any of you are still interested, the young research scholars, you can contact this National Center of Polar, NCPOR, in Goa, and find out about how to submit proposals. And if you are interested, you can find out more details about your programs. Now there is in 2012, there is a third Antarctic Indian station in the Lashman Hills area in Prince Bay, which is a very, very modern and upmarket, as you can say, research station where since 2012 lots of work has been done. And since this part was attached to India in Gondwana Land Confederation, so lots of hopefully lots of interesting results will come. Although this area has been thoroughly explored by Australian geologists, because their station is very close by, and has been working there for last 50 years. But I'm sure there will be lots of scope to work to carry on this further research. Now, before I finish my lecture, another just warning about global warming. You know, the cold places are the first areas to show that warming of Earth. So naturally, the cold places on the world is Arctic, Antarctic, and Himalayas. So all the places are really showing very warning feature of global warming. And all the ice shelves of West Antarctica, since West Antarctica is warmer than East Antarctica, and they have more ice shelves in that region, they are melting. And the biggest danger, as it's called Doomsday Glacier, is the Thwaites Glacier in West Antarctica, where part of the glacial tongue has been melting very dangerously. Because if this glacier melts, it will be like opening of a corkscrew, and all the rest of ice sheet of Antarctica will be exposed to the warm sea. And these days, because of the rise of temperature in Antarctic region, where in 2020, 18.8 degrees Celsius were reached, that the sea ice are not forming. If sea ice are not formed, then the sea gets more warmer, because Antarctic ice sheet, both at the main ice shelf and the adjoining sea ice, reflects the sun rays and keeps the Antarctic region cold, and it keeps a balance. But if the sea ice are not formed or melt, then the dark colored sea ice will not reflect any sunlight. Moreover, it will absorb sun rays and become warmer again. So now all the ice shelves are exposed to warm sea underneath, and they are collapsing very fast. So now there are lots of glaciers are retreating, and it is in a danger of really sea level rise. And it was the scientists did not consider this rise as fast as it's going on now. So this has affected marine life because the water has become less saline, more sweet. All the ice shelves are collapsing. Then penguin rookeries are affected because sea ice is not forming, because those are the rookeries of emperor penguin, and a large number of rookeries are gone. Soils are contaminated, and the chemicals are found in lots of Antarctic flora and fauna. So we have a thing to really worry about. I think that's all for today. My voice is also giving away. So thank you very much. Shantanu.
No, it's okay.
Get out of it. Raise it out.
Thank you. Thank you very much, madam. It was an excellent talk. It was a pleasure to hear you again. Let's give a round of applause to madam. So we will take few questions.
Yeah.
Please raise your hand and yeah, Vishal, please go ahead. Vishal, I see you have a question.
শুনতে পাচ্ছি না শান্তনু কি বলছে
No, that's insane.
Vishal, would you like to ask?
I think Professor Dhruva Mukhopadhyay has a
Okay,
query.
and no problem. Okay.
Yes,
Sir, please go
Sudipta,
ahead.
I am curious that how you measure directions in with your compass in Antarctica.
Oh yes, that's an interesting thing because the magnetic pole is
almost
right.
perpendicular.
Right. Yes, we have to correct it. I think it's about 28 degree. There was a deviation of geographic South Pole since we are close to geographic South Pole in 70 degree south latitude. We have a deviation of about 28 degree. We used to note down the real the measurements, whatever we are getting, but then each evening we used to correct it with adding 28 degrees. Yeah.
I think some compasses also have provision for correction for declination, isn't it?
Maybe, but our compass didn't have that, so we have to take that. Now maybe Brunton.
Now they have, yes. Brunton as well as silver compasses, they allow.
And the other
Maybe, but our
problem
compass have to take
is
care of that.
because a compass needle would not be horizontal because the lines of force are almost perpendicular at the South Pole. So how do you take care of that, about the inclination
That
of the
was
needle?
at 70 degrees south, 70 degree, that was not a big problem. Maybe
was not a
further south it would have been more difficult, but we didn't find it much difficult.
So you could use a normal
could-
Brunton or a compass.
Yeah. I took silver compass and that worked well.
That worked. You had no problem with the movement of the needle.
No.
Okay, thank you.
Thank you, sir. There is another question by Supriya Kaviraj. Hello, please ask your question. Unfortunately, we can't hear you. Anupamda, please go ahead.
Sudipta Di, thank you for an excellent talk. Although many things were already we have learned from you, but it was a very mesmerizing experience to listen to you again. My only query is not really geological. It's just a general query, is that how come in a 4.5 or maybe average 2.5 kilometer deep ice sheet, how you are having ice topography. Are they mimicking the underlying topography, basement topography?
No, it's like a like mm, like more or less like a upturned turtle, because it was all the underlying topography are all covered by this thick sheet of ice.
Exactly. That is what I
If it
was
was
thinking.
thinner, then perhaps it would follow the topography. But now it's more or less dome shaped, dome, dome shaped itself.
Yeah, that is the general. So on, if you are, I mean, that dome will be of a very large scale. So if you are actually standing on the ground, then it will be almost like a flat plane in front of you, isn't it? Because you
Yeah,
will be.
sometimes it is uneven because of this large sastrugi.
Hmm.
They are kind of uneven, and closer to the mountains, because of the glaciers, they are coming from the height of the, they are sloping. So,
Okay,
but
so
if
they are
you
like the
are
toe
away,
of the glacier.
you are away, then it's almost flat.
Okay, so they are basically the thickened toe of the glaciers that you are seeing as a high, kind of high mountains
Yeah.
in the near the coast.
Yeah.
Okay, okay, thank you.
Thank
There's
you, Anupamda. There is another question written here. Uh, I will read it for you, ma'am. It's written in Antarctica, some area rock exposed in Antarctica. My query, what is the reason behind the rock exposed in Antarctica in the very cold climate? Not sure I did understand the question. If anyone understood, maybe.
I think what she wants to know is that why at some places the rocks are exposed, where in most of the places they are under
Okay.
thick under the
Oh,
ice cover.
okay, okay. Because they are higher than the thickness of the ice sheet. You know, that's just the way the islands are seen in the sea, because they are higher than the water level. It's the same way you see the top of the mountain above the ice level. If the mountain is higher, then you can only see above this thick ice sheet. That's why only the this coastal region where the rocks are exposed, they are actually the tips of the mountains, mountain range.
Jyotima, I have another question.
Yes, yes, Anupamda, go ahead.
Shwetadi, I mean, I think that in Antarctica there is no regular cloud cover or snowfall. Rain kind of snowfall is there or not? Or it is
No,
only the ground snow?
only the coastal region. In the inside, there is no rain because the water air is so cold that it can't hold moisture. That's why Antarctica is compared to desert climate, because the moisture is not there. Only around the coastal region there is some snowfall, but usually during the blizzards, like sands fly during in the desert, these ice crystals, there are lots of, the whole top is covered by ice crystalline ice cubes,
Okay.
like sand, a little larger than sugar grains, and they fly like just the way sand flies in a storm, and they are deposited, um, they cover all the, but they are not so snowflakes, they are crystalline ice.
So the permafrost, that is the inside, the inland thick ice cover, that ice sheet, what is considered or what is told about their origin? I mean, are they all seawater frozen at some point of
No,
time, or it
no,
was
no, whole thing is sweet water.
sweet water? So then there must have been very big lakes or something at some point of time which must have frozen. Is there any idea
I
what?
think it's a continuous collection. I mean, I'm not an expert of how this huge ice sheet is formed, but whatever I read, that it took millions of years to form this huge ice sheet. It started and then gradually increased. Whole thickness has added and added and added, and maybe the temperature was also um, I mean, ice fall was also at this point of time. It is only coastal, but maybe
That is
in
what
other part it was in the inside also. So I'm not sure about
there
that.
must be a source of the moisture or
There must be some source of this huge ice sheet here.
Ma'am, there are two more questions in the chat box. I will read it for you. One from Raghubir Rai, and he asks, ma'am, my query is, if we see whole Antarctica continent, it can be divided into two parts, as you said, eastern part Precambrian and western part younger, probably Paleozoic. So, were these two part of the same continent from the beginning, or the western part came later and collided with the eastern part and formed the trans-Antarctica mountain range?
Yes, there are. I mean, naturally, the Trans-Antarctic Mountain was formed uh, in a in some mid history, geologically, the earlier Precambrian eastern part was much older, and this orogenic belt of Trans-Antarctic Mountain were formed much later stage. The way the mountain ranges are formed, the tectonic movement or whatever movement, but then whatever the scientists now have sort of postulates that it happened time and time again. It didn't happen at one go, because the fossils that are found Precambrian, even in Transantarctic mountains, there are Precambrian rocks, earlier rocks. So time and again, this mountain has risen, peniplaned, and risen again. So it must have formed in geologically sort of Paleozoic, Devonian in different times. And I don't go into the details of geological history of the whole Transantarctic region. It has a complicated history, but it did not form at one time. Repeatedly, it has been deformed, peniplaned, and rose again.
Thank you, ma'am. There is another question by Vishal, and he asks, in Antarctica region, there is ozone depletion. Does it affect on scientists' health?
Not really, because it's difficult to. I mean, even it does. It's difficult to assess, because you have to be there under a long period of time, and usually it is worse during summertime. The ozone layer is much higher, and during the winter time the ozone layer comes down closer to the Antarctic because of this temperature. And this whole thing about this, nobody no it can only be seen, um, I mean, it's only been seen scientifically. It's difficult to feel it and difficult to see the effect of it. And it is not for just 1 month or 2 months or even 1 year, doesn't create any long-term effect.
Okay, thank you, ma'am. The another question: were there any? This is by Chinmay. Were there any wind and blown ice induced geomorphic features that were observable on the exposed outcrops?
Say it again.
So he's asking whether there like any aeolian features on the ice, like geomorphic features on the ice by the wind.
There must be, but I did not study that.
May I ask this question again?
Yeah.
Yeah, I wanted to know if there were any wind-blown features on the exposed rock on the outcrops.
On the rock, yes, there are. Interestingly, lots of rocks have this honeycomb feature. Due to ice crystal collected in the rock and then wind blown. So you will see lots of When I had a collection somewhere, Shantanu, can you give me from the behind that the Kalu Pakistan?
Where is ma'am? Is ma'am there?
I think the connection is lost.
Yeah, that's what I thought. I can't. Nilanjanda, can you call Shantanuda once if you are? Of course, I can call him as well.
I'm calling him. He must be arranging things also. Anyway, I'll call him. It's not picking up.
I just hope that they realize that the connection is lost. Maybe ma'am is keep.
Okay, so just you can show.
Yeah, okay,
Yeah,
ma'am is there. Yes, ma'am.
I don't know. You can see the features. দেখতে পাচ্ছ?
Yes, ma'am. It is.
Honeycomb features.
Yes.
Good. And the whole rock, whole things can be covered with this kind of honeycomb weathering.
What is this rock, madam?
Amphibolite.
Okay. So we go to the next question. Pratish, please go ahead.
Thank you, Jyotirmoy. Ma'am, my question is, I saw some dikes in your photographs. Apart from these isolated dikes, have you seen any dike swamps? A cluster of dikes in that?
No, not in Schumacher Hills. No.
In Fanner also, no dike swamps.
No.
Thank you.
Nilanjanda, go ahead.
Madam, thanks for showing us Antarctica. Madam, I just curious.
Just see yourself.
I think I've crossed the age.
No.
Surely in the next life that I have, I'll surely go there. The thing is, madam, I learned a little bit when I was reading about the geoid of the Earth. The Western Antarctic has a low gravity compared to the Eastern Antarctic region. What could be the reason for that? You said at one point of your lecture that the crust is depressed by 600 meters, if I can recall it correctly.
Yeah.
So because of the weight of the ice, probably, that you say.
Yeah.
Now, why does within the continent, why does the Western Antarctic have a low gravity than the eastern part? Any idea about?
No.
I think it could be because of the rock types. Because I assume that East Antarctica is basically high-grade granulite facies rock, and the Western Antarctica is a sedimentary rock. Mostly because of that, it could be.
Yes, I also think so.
Changing.
Because of the difference in rock, maybe the gravity anomaly will be different.
Yeah.
But the ice cover in the Eastern Antarctic is lower than the ice cover in the Western Antarctic, probably.
Ice cover in peninsula is lower, not the entire West Antarctica. Part of where the Thwaites Glacier is situated, that part ice cover is there. Only the peninsular region is less ice cover. But definitely ice cover in East Antarctica is much larger in size than the Western part. Yeah.
Yes.
Ma'am, these small islands that you talked about, which is currently Antarctica is an amalgamation, as you said, of these small islands.
Yeah,
Are
if
they
the
like,
ice is removed, then it
yeah.
will be like that. Yes.
So are they like proto-continents or just land masses separated by ocean? How would you?
I mean there are chance that there are protocontinents, but I think since only 2% is only exposed, I mean of course researchers are going on. I am not aware of the present day recent advances in research, but it in my general knowledge, at least it can be at least one or two or three protocontinent, but I'm not sure. It's just a sort of postulation.
In fact, you are correct. Till now, people have thought that there are a number of cratons. They have come closer and amalgamated together at different time span, as you said. And in fact, for another question that person was saying about the mountain belt formation, it is also true that since it is covered with ice, we are not sure why this mountain has formed. But from the seismic data, they have done some geophysical investigation across it, and they found that this could be also resulted from the change, removal of the ice sheet to maintain the isostasis. Some part of the craton has been uplifted. This one group of people are saying like that for the evolution of this Transantarctic mountain. But this is not, there are many working on this aspect because this is very challenging work to do. We really do not know till now what is the real cause of this formation of the Transantarctic. At least recent studies say so. Yes, sir.
Yes, sir.
Sir, you are muted.
Sir, yeah.
What is between the two islands? Is it some? I mean, it can't be void. So
no. There. People are saying that there are some.
There should be
oceanic
lithosphere.
Oceanic lithosphere, not ocean.
It will be. If I can go back, Parvo.
No. The question is whether they are encyclic basins or they are actually oceanic lithosphere that is separating the two protocontinents.
Yeah.
That is what I think sir is asking.
Yes,
true.
I think it could be. It could be depressed below the sea level now, and it's I don't know if there is any confirmation that there are oceanic.
There are two models. Now there are two models. One model is saying that there are ocean basins, and another model is saying that there are not that ocean basin. Ocean basin could be there, but not of very high magnitude. But because of this removal of the ice sheet from the top, this mountain has come up. Upliftment of mountain have come up like that.
But why then this differential uplift?
And that is the reason they are saying that at a very localized zone, the ice thickness of the ice was much higher than the lateral from their lateral counterparts.
Is that supported by the actual measurements of thickness of ice?
They have shown something, but I'm not sure. But they have shown something.
Okay.
Because something in one model they say that this is not typical. Convergent tectonics that we generally talk about for the evolution of the Himalayas.
Okay, if any other question, I think we have kept.
Then it will not be a fold mountain belt.
No.
Shantanu?
Yeah, they don't say like this.
No, Transantarctic has a mixed. They're saying mixed. Yeah, mixed.
In fact, the falls are very, very steep. Very steep fall. Yes, sir.
it have now the present, they are saying now the present height is due to a fault, although it was a folded mountain. Another interesting
There
thing
are indications of some rift valleys also in Antarctica. I have also co-authored one paper with Professor Pant, NC Pant, where we argued, actually it is more of their data, I only assisted in the structural interpretation, that they are indicating that there are some deep rift valleys which are following the crustal anisotropy, I mean the gneissic basements in many cases. I do not exactly remember that this somewhere near the Prince Elizabeth Land, within the Prince Elizabeth Land, but exactly that place names I have forgotten because I'm not very much used to the Antarctic geology. That is now I think many of the other groups, Russian and other groups, they are also trying to find out the deep rift valleys. If there is an active, I mean, I don't know exactly what is the age of those rifting, but if the rift valleys are a cause of separation of the continental masses, then that is another possibility.
So the oceanic crust has come up in the rift valleys?
No, that is not known. They are too thick ice cover to find out those things.
So they are doing it
from the geophysical data, followed by some whatever little geology they could do from the rock types, and also some interpretation. From that, they are suggesting right now.
Okay, we go to the next question. Priyanka, please go ahead.
Thank you, ma'am, for always inspiring us with your wonderful lectures. I just wanted to know, as a major part of the rock exposures are under the ice sheet, how did you start your, from where did you start your structural mapping? And it must have been very difficult to correlate and, like we do here. How did you start that in Antarctica during your expedition?
Yeah, the advantage in Antarctica is there are very little rock masses are exposed, little percentage of rock masses are exposed, but where it is exposed, it's 100% exposed because there is no vegetation, and these rock areas are top of the mountain hill. There is no permanent ice sheet over it. There may be side of it, but these are what. Suppose I walked in Schumacher Hills. This 35 square length of this range is almost 90% exposed. There may be locally patches of ices here and there, but it can form continuously. So if you form, of course, this is a very easily accessible area, Schumacher Hills. But in Humboldt Mountains, which is a large mountain chains, there are large area of ice covered. So they have to do it piece by piece, and sometimes it's not possible to do it in the interior region. So they have to almost postulate what it could be. But otherwise, you have to make do with whatever is you can see and study. So that is your starting point.
Okay, ma'am. Thank you.
Okay, any more question?
And now I remember, that is called a Lambert Graben, where these people are.
Yeah. I was also thinking, what is
Lambert Graben. So there is a project by, I think, British Geological Survey called IceCap. This IceCap project, they are trying to find out by some deep drilling as well as detailed radar images, subterranean radar images about the basement configuration. But whatever little data they could understand, and that time we also did some analog experiments, and then we interpreted that there are some deep rift valleys possibly in this part. I mean, those are post-Pan-African rifts. But of course, these are all interpretative only.
Actually, the technology is getting better and better. So Antarctica is still quite unexplored, and we hope to get more and more definite answers to lots of questions as time passes.
To end this, before you close this meeting today, Jyotirmoy, can I add something here?
Please, please.
Sure.
The thing is, Pratis asked Madam that whether you have seen some dikes from there. So she said no. So when I went there, I didn't know anything. I just went. I started to learn things from there, and since I worked alone, so now I developed some sort of confidence in doing that. I think so. So the thing is, now when I see now the Google map around the area that I worked, I find lot of things that I have not seen there. Now Google Maps are so clear, you can see lot of ductile deformation structures clearly sitting in our office. Now I can tell you one thing. I have seen some thin fault-like thing. That time I did not really understand those properly. I think I talked to my colleague in presidency also regarding this. I'm sure these are pseudotechnites.
Yeah, I think so. We also suspected that.
These are pseudotechnites, and there are a lot of pseudotechnites in the western part of Schumacher Hills. If anyone wishes to go there in Schumacher Hills, please do check this. In the western part of the Schumacher Hills, along the map that we did, sticky gneiss zone, after the calcilicate, you will find lot of pseudotechnites. So that time we did not have the idea of this. At least I did not have the idea of this type of thing. But if I go now, we can explore more. So the thing is, there are a lot of things unexplored. You understand what I mean? So thank you, madam, for giving me this opportunity.
Even in India, if you go in some area year after year, then you always find some
new things. Every time.
And in Antarctica, we have a time span of 1.5 months of good weather. So you have to always hurry and do things. So we must have overlooked a lot of things. And unless you are interested or you have some knowledge, pre-knowledge about what you are looking for, all of us must have missed a lot of things. So anyone can go and find out much more, have more information these days.
As you said, the advantage in Antarctica, as you said rightly, is that even if there is little exposure, there's a very good exposure.
Very good exposure.
Mostly, there is no vegetation plus ice polishing. There is no.
The polishing is there, but in some areas there are glacial polishing. But there are plenty of other areas also.
And it is continuous.
And continuous. Whatever is exposed is continuous.
Exactly.
Ma'am, these coal beds, how thick are they?
At places they are sort of economically thick.
Wow. Okay.
But not really economically. Had it been in any temperate region, it is economically. In Antarctica, this is no use. That is the only economic reserve found in Antarctica. Coal. Otherwise, no economic size reserve is found in Antarctica.
Okay. As such, I think exploitation is totally banned internationally, isn't it? I mean, no one can exploit anything, any mineral resource from Antarctica.
So I think our Professor Dilipda has something to say. He is smiling. Yes.
Can you hear me?
Yeah.
Okay.
Please go ahead.
I am glad to see Sudipta after Delhi RDS.
I'm also glad to see you after a long time.
And I'm really very happy that his mind is as fresh as ever. Because he can say the names and rocks and everything. I keep forgetting names and all the time. Although I remember Sudipta. The first time I listened to Antarctica talk was in late 70s sometime. And there's an Australian meteorologist who had done some work in, I forget his name, who did some work in Antarctica, because he had worked in everywhere there is a granulate kind of rock, Pygmalion rock. And I remember still that when Professor Naha entered with this Australian gentleman, he said, "Oh, people should listen very carefully because there may be a question on Antarctica in the upcoming GSI examination." And I appeared for the GSI examination. Fortunately, I was selected. And then there was really a question on Antarctica. And he came back and said, asked Professor Naha, "Did you set the question paper? How did you know?" He said, "No, I just guessed. That's all." And then, of course, I heard Sudipta ji before. And today also I learned quite a few things from Sudipta ji. Thank you, Sudipta ji, and God bless you. And
Thank you, most welcome.
Stay healthy. Stay healthy.
Thank you.
As you are, as you look today.
Yes.
Thank you.
Thanks.
जेटली साहब कुछ कहना है आपको?
Thank you, ma'am, for an excellent story on Antarctica. Of course, I have heard several talks, but I feel now it is as fresh. And the way you were speaking with your memory, sharp memory, fantastic.
Not really. Not these days.
No.
I mean,
My voice is really
it's quite good, quite clear. I had the opportunity of working with an East German professor who has visited Lambert Rift, and he had found a series of dikes extending for about 10 meters with a width of about 1 meter. And he had a strong belief that he should find similar things in the Mahanadi Rift. So he came to me and approached me to have a collaboration, and we had collaboration with them. Until then, there was never any dike reported from anybody from Mahanadi Rift. He has come and we have searched for it for about 2 seasons, each season consisting of 6 weeks, and we have found about 10 dikes. And the age was 120 million years. And he was confident that he should find dikes, and we have found. Such a great clarity he had, and he has worked extensively on Lambert Rift. He has visited 3-4 times, it seems. And he was staying in East Germany, and he did not have the opportunity to visit India. Once they were united and an INSA exchange program, he came to India, he visited NGRA, and he came to me. So that's why we could formulate a project, and then we had worked out a bit on these lines. So there is a strong correlation between Lambert Rift and Mahanadi Rift. Many papers have been published on them.
I will tell you one thing, I remember one thing. When we first time went to Antarctica in 83, we did not have a base map of Schumacher Hills. And it was really tough for us. Had it not been the German geologists, they have a airborne survey. From airborne survey, they have a beautiful airborne map, and they gave us copy. And because of that, we could walk on it. Otherwise, we could not even walk. I mean, we went to Antarctica in the first time almost unprepared, without any proper map, proper topographical map. So anyway, I mean, I think 40 years ago, we did justice. Whatever we did justice, that we did justice. Because, but still there are a lot of things in other areas, but there are a lot of things to be done in Schumacher Hills as well as Humboldt region. Humboldt region is, I mean, the inner mountain region is totally, very, very scantily mapped and scantily reported. Because it has lots of logistic problems in those areas.
Okay, Jyotirmoy Jyotirmoy?
Okay.
Okay, yeah, I think, yeah, ma'am is also tired. I mean, it has been, although it was a pleasure for us, I think, yeah, she's also, I could see that she's coughing. So let's just stop here because we don't want to, overutilize the opportunity. However, thank you very much, ma'am,
My
for being
pleasure.
here to speak today.
Okay.
Okay. See you.
Okay.
Thank you, Sudipta ji. Thank you.
Thank you, everyone.
Thank
you,
you for
everyone.
this opportunity. And for me, it was a great adda. I enjoyed that part more because my voice is not really behaving properly these days, and I like to listen more than talking. But anyway, this adda, when it's the later part, I enjoyed when it was more adda than giving a lecture. Thank you very much.
Ma'am,
Sudipta, and all
just,
that. Thank you.
just one.
Can we have a group photo?
Yes, of course.
Jyotirmoy?
Yes, absolutely, ma'am. Just one thing. This time, ISA Bhopal is organizing RDS 8, so it will be great if you can come. We will be really happy to host you here.
You're
in
telling
October.
me?
Sir,
Yes,
ma'am,
he
in
is asking
October-
you to come to Bhopal.
in
ধ্রুবদা তো
October-
যাবেন আশা করি।
Yes, ma'am. What did you say?
I mean, I hope to go definitely.
Yes, ma'am.
But,
Okay. Okay.
I mean,
Okay.
last time also I missed because I had this COVID thing just before the RDS. So I hope my health will permit. So,
In Delhi, of course, I was fortunate to have almost everyone, all the senior
yes,
friends
right.
and our teachers. Only I think Professor Dhruva Mukhopadhyay at the last moment, he had some problem. I think some litigation related to his housing and something. So he had to drop out even after all the arrangements were done. Otherwise, almost everyone was here, including Sudipta Di and many others.
It was very enjoyable meeting all of you. And Shantanu Mishra is totally silent today.
No, ma'am, I am here.
I just noticed. Otherwise, you are quite vocal in all other
No, I am
meetings.
here. When Nilanjana and Anupamda are there, I think I should remain silent.
Then
Always Shantanu
respectful.
only will speak after everyone finishes. Ostader ma shesh ratre bole na.
No, I said I requested for a group photo. And I am
just
sure
take-
Jyotirmoy will take a
I just
screenshot.
take a group
But
photo.
you are presenting yourself only as a dark screen.
I don't know why it is not coming. I have no clue actually.
A dark screen written as Shantanu Mishra.
এই দেখলাম তো ছোট্ট নাম লেখা।
Okay, now it should come. Yeah, you can see me.
Okay, I will take a picture.
I can pledge Shantanu that next time I'll never talk.
Better you don't keep the promise.
Okay, I will just take a photograph. All right, it's done.
okay.
Thank you, everyone. Thank you.
very much.
Thank you.
Bye. Bye.
Share the photo, Jyotirmoy, in the group.
I will do that. Yes.
Please. Thank you.
Pratish came later. Pratish came later.
You can take another photo.
I will take another. I will take another.
I suggest that
It was good.
one by one we leave and new people will automatically join and you keep taking photographs. That will be the better.
Madam, I must thank you for showing us a young Shantanu. He's completely different from the demography he presents today.
All of you. I remember you as a student. You have changed. You have similarly changed your demography.
Yes.
Chalo.
Okay.
Thank you. Thank
Okay.
you, ma'am. Bye.
Okay.
Bye. Good night. Good night.
Good night.
Good night.